Welcome! It's 10-Frame Tile Tuesday at KP Mathematics. Today we continue our series comparing base 10 blocks and 10-frame tiles, showing the difference that the 10-frame makes. Last week's video ended with a count of 10, when base 10 blocks traded the 10 1 blocks for one rod, and 10-frame tiles made one group of the 10 ones. Today's video focuses on the place value exchanges that occur when the count to 100 continues past 10. With our focus on place value exchanges, we'll pick up at the count of 19. Adding 1 in the ones place makes 10 plus 10, and an overfull ones place. To represent 20 correctly, we make a trade with base 10 blocks, and we make a group with 10-frame tiles. Counting continues. Skipping to 20 plus 9, or 29, we next have 20 plus 10. A place value exchange is needed to represent 30. 30 plus 9 is 39. 30 plus 10 requires a place value exchange to represent 40. As the count continues, we see that trading creates a growing accumulation of discards, while grouping creates tiles of 10 that incorporate the counted ones. We pick up the count at 80. 80 plus 9 is 89. 80 plus 10 requires a place value exchange to represent 90. 90 plus 9 is 99. 90 plus 10 requires a place value exchange. And you know what will happen next. A chain reaction is activated. Because the 10 ones have moved to the tens place, the tens place is overfull. For base 10 blocks, the 10 rods are traded for one flat and discarded. The flat appears in the hundreds place. For 10-frame tiles, the 10 tiles of 10 are grouped to become a tile of 100, which then appears in the hundreds place. Actually, this picture shows the correct placement of the tile of 100 in the hundreds place. To review, the base 10 block procedure is messy and disorganized, creates 110 discarded blocks, misrepresents the way numbers behave in place value exchanges, and produces a total, a flat, that does not incorporate the counted pieces. The 10-frame tile procedure, on the other hand, is highly organized, uses a minimum number of tiles, replicates the way numbers work in place value exchanges, and includes all the counted pieces in the tile of 100. The most important differences between base 10 blocks and 10-frame tiles are attributable to the 10-frame. A 10-frame in every place provides the conditions for students' meaningful base 10 work. A full 10-frame, the physical representation of an unacceptable quantity in that location, serves as a signal to group, and grouping makes trading unnecessary. The manipulative that children use makes a difference in what and how they learn. The 10-frame shapes learning by promoting base 10 thinking. Children begin thinking in terms of 10. In contrast, there are significant drawbacks by using base 10 blocks. The meanings we impose on base 10 blocks to make them work may not be the meanings that children take away. When we must impose meaning onto a manipulative, we open the door to confusion, misinterpretation, and inaccurate conclusions. The manipulative children use influences their understanding of mathematics and impacts the way they perform mathematical tasks now and in the future. Please join us next Tuesday when we show how the 10-frame model extends to the entire base 10 system. See you then.